You ask ChatGPT a complex math problem, and it gives you an instant answer, sometimes wrong. But ask the same question to OpenAI's O1 or DeepSeek R1, and something different happens. The model pauses, thinks through the problem step by step, and arrives at the correct answer. What changed? The architecture of reasoning. In this video, you'll discover how reasoning models are fundamentally different from traditional LLMs, why they're revolutionizing AI in 2025, and what makes them think before they respond. Let's start with how regular language models work. When you prompt GPT-4 or Claude, they generate responses token by token in a single forward pass through the neural network. Think of it like autocomplete on steroids, predicting the most likely next word based on patterns learned during training. This works incredibly well for most tasks, but here's the problem. Complex reasoning requires something humans do naturally, thinking through multiple steps before answering. Traditional LLMs can't pause to think. They generate their first thought as their final answer. Enter reasoning models, LLMs specifically designed to think before they speak. The breakthrough came with OpenAI's O1 model in late 2024, followed by DeepSeek R1 in January 2025. These models introduced chain-of-thought reasoning as a core architectural feature, not just a prompting trick. Here's how they work differently. Instead of jumping straight to the answer, reasoning models generate an internal thinking process, a hidden chain of reasoning steps that you don't see in the final output. The key innovation is reinforcement learning from human feedback applied specifically to reward longer, more deliberate reasoning chains. The model learns that spending more compute on thinking leads to better outcomes. Think of it like the difference between a reflex and deliberation. A traditional LLM is like catching a ball, fast, automatic, pattern-based. A reasoning model is like solving a chess puzzle, slow, methodical, requiring multiple moves planned ahead. Let's zoom into the technical architecture. DeepSeek R1 provides excellent insights because it's open source. The model uses a dual-mode architecture with two distinct processing paths. Path 1, Thinking Mode. When the model detects a complex problem, it activates reasoning mode. Here's what happens. Generates multiple candidate reasoning chains in parallel. Each chain explores a different approach to solving the problem. Self-verification step. The model checks its own logic for errors. Iterative refinement. Loops back if verification fails. Path 2, Fast Mode. For simple queries that don't need deep reasoning, like what's the capital of France, the model uses standard transformer inference. No need to waste compute on obvious answers. The intelligence is in the routing mechanism, a lightweight classifier that decides which path to take based on query complexity. Here's the breakthrough moment. DeepSeek achieved 90.2% accuracy on advanced math benchmarks, compared to GPT-4's 74.6%, while costing significantly less to run. How? By only using expensive reasoning compute when actually needed. So when should you use reasoning models versus traditional LLMs? Here's the practical breakdown. Reasoning models excel at complex mathematics and formal logic, multi-step problem solving, coding, debugging, strategic planning and analysis, scientific reasoning and hypothesis generation. Traditional LLMs are better for creative writing and content generation, conversational chat and customer service, quick factual retrieval, real-time low-latency applications. The trade-off? Latency. Reasoning models are slower by design. That thinking process takes time. DeepSeek R1 might take 10-30 seconds for a complex problem that GPT-4 would answer in 2 seconds. But for problems where accuracy matters more than speed, like medical diagnosis, financial analysis, or research, that trade-off is absolutely worth it. We're just at the beginning. The entire industry is racing to build better reasoning models. Meta's Llama 4 series is incorporating reasoning capabilities. Google's Gemini 2.0 promises enhanced chain of thought. Anthropic's Claude is exploring similar architectures. The future isn't choosing between fast models and smart models, it's having models that know when to be fast and when to be smart. The bottom line: reasoning models represent a fundamental shift in LLM architecture, from pattern matching to actual deliberation. They're slower but dramatically more accurate for complex problems. Hit subscribe so you don't miss new videos, and drop a comment. Which reasoning model are you most excited about?